Patch? We can't patch. What do you want to do? Turn off the power grid? Patch? We can't patch. It takes 3 days to file the safety paperwork. Patch? We can't patch. The only way to get to the device is via helicopter. Good afternoon. My name is Luciano Moretti, and I'm a senior research engineer with Verve Industrial Protection based out of Madison, Wisconsin. I have 20 years of experience communicating with embedded devices in medical, commercial, and industrial space. In my current role, I reverse engineer custom industrial protocols for interoperability and vulnerability analysis. Verve helps critical infrastructure companies secure their devices by identifying them, cross-referencing that with known vulnerabilities, and hardening their systems. Today we're going to cover what is OT and ICS, how it differs from IT systems, the unique challenges of securing OT and ICS, attack surfaces, existing threats, myths regarding mitigation, and what we can do to move towards a better system. Operational technology and industrial control systems are the computerized, programmable devices that control interactions with the physical environment. They're used to control and monitor processes. Examples include controlling manufacturing lines, oil and gas transport and refining, power generation plants, fire control systems, and environmental controls. Operational technology systems are commonly made up of many components, devices that are networked together. Sorry, 1 second. Networked together. Edge devices are often custom embedded platforms running on microcontrollers or application processors. They're as diverse as we pick microcontrollers running bare metal, ARM Cortex-M chips with embedded real-time operating systems, to Windows embedded or Linux-based devices. And the devices are usually paired with one or more off-the-shelf computer system with custom software for setup and monitoring. In factories, we have PLCs, robots, valves, mixing chambers, and burners. Power generation and distribution has substation controls and automated switching. Lock and dam has power generation, spillway, and sluice gate controls. I hit the wrong button.
Yes, I made a sign.
Oil and gas pipelines have pressure and temperature monitoring, gas metering, and automated valves. And production facilities have process controls, automated valves, and fire suppression systems. In IT systems, okay. Is there anyone here who's an IT administrator? Couple quick questions for you. What's the oldest version of Windows you support? Windows 10? Okay. Okay. In an IT environment? Wow. How often do you guys usually replace an average user's computer? 3 to 4 years? And are any of you running Linux-based systems? What's your oldest kernel version? I'm not going to mention. Will not say. Okay. Okay. Well, normally it's fairly modern, but so most of equipment in an IT environment are in centralized locations on fast connections. Equipment usually servers, laptops, desktops, switches, and wireless access points. Usually PCs running Windows 10 or 11, hardware on a, as he said, 3 to 5 year replacement schedule. And if something breaks, often a spare is available overnight via CDW or Amazon. In contrast, in an OT environment, we have all the devices of IT, the servers, switches, desktops, plus tons of specialized hardware. Equipment is scattered across manufacturing floors, and with some enclosures in isolated locations on wireless connections including cellular, microwave, radio links, and LoRa. Devices are in place often for 10 plus years, We still commonly see XP and CE in the field, and Linux devices with 2.4 or 2.6 kernels. We just recently had to install Debian 6 to support a device we were installing in our lab. Devices usually run a customized OS without a package management system, such as embedded Linux running using Buildroot or Yocto, or microprocessor-based systems running RTOSes like FreeRTOS, MQX, QNX, or VxWorks. And finally, device spares could cost hundreds of thousands of dollars, no longer be manufactured, or maybe manufactured to order. We had one device recently that we were looking to get that, and the cost would have been over $1 million in outlay and required a $750 an hour support contract. To summarize, equipment is scattered across the organization and is running on older operating systems and software. So why is OT running so much old software? Security doesn't do you any good if you can't produce your product. So OT systems must remain operational except for very small scheduled maintenance windows. Why are we this way? Factories are often pipelined, are not in a batch system. So shutting down means scrapping product. Shutting down may lead to service outages, especially in industries like power industry, or may require redirecting oil and gas to other facilities. And in extreme cases, it can cause physical damage to the systems. The example I like to usually hear is glass factories, where if the glass cools in the pipes, you have to remove the pipes and replace them before reflowing the hot glass. I'd like everybody to raise their hand right now. How many of you lower your hand if you've rebooted your computer in the last day? Last week? Last month? We got one guy in the back, or two guys in the very, very back. What's your uptime? Sorry? 3 months on your personal? What about yours?
Probably about the same.
About 3 months? When you're in OT, you have to ask, what do you need to do? What risks do you have in order to patch? How many of you have had an OS update or patch crash your system? How many of you have had an OS update force you to reboot your system in the middle of something? Have anybody here flashed a hardware device? If you're lucky, it takes minutes. And if you're unlucky, it fails during the middle of the update, and you end up with what people generally call a brick, a device that doesn't work and can't be fixed. It's not a huge problem if it's a $300 router that you can order online or pull one from spares and replace quickly. But when it's a $3 million distributed control system, it's very different. At what point do you shut down the factory to patch if there's a security issue? How do you verify that that patch does what it says it does and doesn't break something unrelated? It is with equipment as expensive as there is in the OT world, customers can't afford to keep a second spare test network up and running. So if you rushed your patches, you can break production. There was a case where a Windows update to a remote procedure call system broke barcode scanning on production and took production down for several hours, blocking materials moving through the production pipeline. Finally, you have remote sites, which are boxes next to a substation, a pipeline, or similar. We have some devices that we support where a ping of 1 second is considered good. How do you push a remote upgrade to a device over that kind of connection? In the end, the common industry procedure is, if it's working, don't touch it. For attack surfaces, the cost of encryption in OT is real. Devices are often using older IT protocols that don't require a lot of processing power. Many of our systems are either soft or hard real-time systems where the communication load is important. It's getting better now that microprocessors and application processors have built-in cryptography units, but it's still rare and it takes a long time to switch out devices and protocols. Most OT protocols were designed prior to the Industrial Internet of Things, where the expectation is that they were on a private or an air-gapped network. One of the scariest things I've seen is a sales brochure for an I/O controller advocating controlling a harbor crane over 802.11b wireless using WEP and unencrypted Modbus TCP connection. Now, devices are getting better. We're seeing more SSH, netconf using TLS, and other protocols with encryption support. And OT protocols are adding optional encryption as well, such as OPC-DA and SIP security. The other common attack surface is credentials. OT has historically operated where we trust the network and the other devices on it. Often there are no credentials at all. No credentials are needed to talk to the device or even to configure device. If it's on the wire, it's trusted. If there are credentials, they're often way too simple. 4 or 5 digit pins and 8-character limit passwords with no rate limiting are common. If the credentials aren't in plain text they're often obfuscated using cheap operations, often straight XORs with a known number, or just swapping nibbles in the bytes. Finally, many devices have hard-coded support accounts, backdoors, for the manufacturers. When a system is down and is costing thousands of dollars a minute for people, don't want to have to hard reset the system because nobody knows the password. Custom protocols, in my business, for figuring out how to talk to a device and get information from it is great, but it's bad for security. Often they're just a wrapper over an older industrial protocol that they used over a serial console. They were designed in the day when you had to physically plug a serial cable into a device. Now they're wrapped in a UDP or TCP session and sent over the internet. Often there's no login, no encryption, no signing, no rolling codes, which makes most of them vulnerable to replay attacks. Malformed communications often cause issues. Device developers test protocols with well-behaved partners. Usually software to talk to the device is not fully specified prior to implementation, and only the green paths are tested. And edge cases often contain serious bugs. Unsanitized data causes over and underflows and undefined behaviors. I can't name names, but these are a few bugs that we've found and disclosed to vendors. Malformed packets taking out the network interfaces on the device until reset. Out-of-order packets causing the device to stop responding. And a packet sent with an empty data section that caused a hard reset of the system without user data and the user program on it. Private data is often exposed in network captures on the wire. People don't see data or don't think of data that they don't see as a security risk, but it's often there hidden in the packet. We've seen Wi-Fi SSID and network keys for private networks, private OT networks sent in plain text in protocols. If an attacker gets access to the device, this gives them a second channel into the facility. We've seen passwords that are authenticated by the host software on the computer, not by the device themselves. The device sends the password over the wire, the host software verifies it, that it matches the one the user typed in, and then starts programming in the device. Custom software bypasses the password completely. And often we see user passwords sent with weak XOR-style encryption. As a developer at a previous company, I was once asked to send the device password across the network using an unauthenticated, unencrypted protocol. And we have also found a device that dumped the complete user and password list via the public SMNMP query. There are a number of existing threats out there. Probably the most well-known OT malware is Stuxnet. It's thought to have been a CIA Israeli targeted attack on the Iranian nuclear program that caused the centrifuges to spin improperly and gradually fail. It's believed to actually have been introduced to the air-gapped facility on a USB stick by an agent recruited by Dutch intelligence and escaped the facility by an unknown vector, but likely a laptop. HAVOX was designed to map ICS networks and is believed to have been an espionage tool targeting energy, oil and gas, and pharmaceutical. Indestroyer shut down 1/5 of the Kiev power grid. Tridon targeted Triconic's high-integrity safety controllers used in the oil and gas industry and is believed to have caused the shutdown of a Saudi Arabian power station. And recently discovered is Pipe Dream, capable of changing the drive control parameters on Schneider Electric and Omron controllers. It even has a module that uses the update utility installed by default with ASRock motherboards to load malicious Windows drivers. The hackers of today aren't Matthew Broderick war dialing in from his bedroom. All of these are from well-resourced, government-sponsored hacking groups. There are a lot of myths regarding mitigating OT networks. Nobody's interested in hacking our stuff. We're not that interesting. We don't sell that many units. It's not worth the hacker's time to hack us. One of my previous employers used embedded Linux computers in their device, in their system. They had one system in the field that was hacked, and it turns out it was they were running a Ware server off of this Linux computer. They didn't care that it was a critical device. All they saw was a Linux computer on an internet routable IP address. Or they take the Bowman Avenue Dam. It's a tiny dam in upstate New York that was targeted by Iranian hackers who breached a cellular modem. Now, the belief is that it was actually a case of mistaken identity, and they were targeting the much larger Arthur R. Bowman Dam in Oregon. If it's there, someone will try. We only share data with customers we trust. Manufacturers only often sell devices and provide documentation only under a contract. If the hackers can't get the documentation and can't get the devices to develop against, then they can't hack it. Your customers distribute that data to their engineers. They put that documentation onto shares. Employees take that documentation with them when they leave your customers' companies or your company. And that information ends up published on public PDF share sites. And people you've trained as your field engineers leave and start third-party training companies, and their documentation ends up online. And unless you have a strict buyback program, when a customer upgrades or goes out of business, their devices get sold and end up on eBay through liquidators, who often don't know exactly what they have. Determined actors will get the data. But just don't hook it to the internet. Hackers can't hack what they can't access. How many of you have said in your job, man, I wish that data was harder to get? It's just not a viable business model anymore. Businesses are demanding more data about how their systems are performing in centralized dashboards. They want to monitor the production and movement of raw materials to finished product, and they want people to be able to remote in to fix things when things go wrong. Project Shine scanned the public IP space for OT devices and found over 500,000 devices. And we're also seeing lots of equipment that wasn't designed for Ethernet now hooked to it without additional protections over serial, cellular, and other protocol gateways. Even if you can, air gaps are not 100% effective. Just ask the Iranian nuclear program. They're often bypassed temporarily to make work easier and then forgotten, Removable media and laptops move between your unsecured and your secured side of your networks. And you have to remember, viruses spread before the internet. And finally, you have to worry about insider threats, disgruntled employees or plants from government hacking groups. Businesses need the data, and a determined actor will still hack you. Got a little dance music going on. But we've got a firewall. We have the internet over here. They've got a firewall. We've got our IT network. We've got a second set of firewalls between our IT network and our OT network. Only people with OT people are allowed to cross that line. This is probably the most used method in industry. Packets still have to pass through those firewalls to allow for data flows. Bad firewall rules, laptops, USB drives, poorly configured remote access. Audits often find cables plugged in where they shouldn't be, bypassing protections. And finally, they also find many inactive accounts with permissions to bridge the IT and the OT networks. Your segmentation is only as good as your overall security. You need to have tighter segmentation controls and audits. So what should we do? What can be done? Comprehensive security takes cooperation. Device manufacturers, prioritize security. Partner with researchers to help them get access to the devices and information they need to help your customers. Developers, sanitize your inputs, please. Encrypt, but don't try and roll your own. There's plenty of well-tested, embedded encrypted libraries out there. Good encryption is hard. Use well-tested libraries. Oops, sorry, okay. Fuzz test your custom protocols to prevent under and overruns. And work towards making faster or in-place upgrades or faster ones to minimize your downtime. Integrators know what you have where and it's running. Move towards a zero trust network if possible. Otherwise, segment closer to devices so a breach of one OT network doesn't disrupt all of your networks. Encrypt by default. Turn on the optional encryption on your OT protocols if you're using a modern device. And disable unused, unencrypted protocols. Use gateways to wrap your insecure protocols in secure ones. And test your defenses. Try and see if you can get from the IT network into your OT network. And finally, security researchers, file CVEs. Find an OT device and try and find bugs in it. Because there are less people looking at OT devices than consumer devices, but the risks are higher and the lifespan of a vulnerability is longer. Thank you. I have 1 minute for questions. Yes.
Great presentation. Really useful. The biggest challenge I find is when I go to the device, the system manufacturer, they kind of put it in the fine print as the responsibility of the customer. And I think very few customers, what is this doing that?
It's a challenge. I mean, you'd have to, as I said, you need to make sure that the devices themselves aren't as secure as they should be. Newer devices have a lot of optional security features that need to be enabled. But you need to segment your network. You need to segment it close to the device. You need to watch that segmentation closely. And you need to partner with someone to verify that that segmentation is effective. All right, thank you, everyone.